on the back sides. Okay, perfect. So let me introduce myself. My name is Dennis Makogon. I work at Oracle as a developer's advocate. Also, I'm a software engineer from the very beginning of my career. So today we're going to talk about the serverless technologies. Have you heard about that? Just raise your hands. Okay, so let's say half. Uh, so let's start with what we have, let's say, 5 years ago. Uh, we do lots of programming, we do lots of networking programming, we do lots of microservices programming. So this is what we had. We have a virtual machines, we have containers, and also in order to get a scalable solutions, we try to develop our applications in the best way. In order to have a small chunks of code, basically microservices, being deployed in a distributed way to get the most stable and most fault tolerant applications as possible. So we started with multi. So we declared that microservices are the granular units for our deployment model. But things are kind of changing. Uh, since all of us are Python developers, we probably have this decision scheme like almost all the time. So we want to develop, let's say, the web application that do only the REST API or just the simple HTTP API. So we start with something pretty low level, which is I consider for myself as a bottle. And then we say like we need a more flexible, more developers friendly interface. We want to have like extensions. So we moved ourselves to Flask. Then we say like we need a templating, we need more stuff, we need views, we need to develop an MVC application. So we decided to go with Django. But at some certain point, we decided that Django is pretty tough for scaling. So we decided to go to something more scalable, more faster, and we want to use a Python 3. Uh, would be nice to use Python 3.5.2 or even something newer. So we decided to use like IOHTTP, which gives you an opportunity to run a coroutines as a handlers to your HTTP routes. But we still do this decision. We still do try to define what would be the best technology to solve our particular problem. So, and the problem of all of these technologies as they has to be hosted. So basically, you need to care about where you host them, how you manage them, how you scale them, and etc. So these problems are not going anywhere as long as you do microservices. So we started long time ago. We started with monolithic application. Then we all see the 12-factor thing that helps us to shift from the monolithic application to microservices. But the technologies are not standing on the same place. We want to evolve. We want more scalable, more stable solutions. That's why we, as developers, we want to get rid of DevOps thing. We want just to write code, press the one button, get everything deployed, get everything scalable. We don't want to care about the infrastructure. We don't want to care about scaling and maintenance of that. So what's basically next? What's the next buzzword in our development cycle? So this is probably my favorite quote about serverless. So basically, serverless is a technology that helps you to write a chunks of code and get them deployed on a cloud, no matter which type of cloud is that, no matter what kind of provider you stick with. So basically, you write a chunk of code and you get a certain type of interfaces to run this code. Would it be an HTTP trigger? Would that be a messaging queue or any other event on inside your infrastructure? Would it be your physical infrastructure or your cloud infrastructure? So what's the serverless architecture pattern? Because this thing is pretty new. It still doesn't have like an academical definition. So you probably got used to the things like this: uh, client server, pipelines, peers, and master slave thing. So yeah, probably it's master independent thing right now to be Yeah, you probably everybody read the news about Python thing changing everything from master slave to something more polite. But we're in the United States, we're okay with that. Um, so the serverless architecture pattern is not all about that. It's just something different because the serverless is the technology that gives you a way different way to develop your application as you probably get used to with microservices, containers, virtual machines, or bare metal deployed applications. So first thing is a MapReduce thing. So basically, if you did a functional programming in Python, you're familiar with that. If you use Spark, if you use what else? MapReduce, Hadoop. They have the same type of technology where you can do when you can do map data and apply the reduce function in order to get a valuable answer from your data sets. But at this moment, imagine that all of this you can do with a serverless, which gives you a certain flexibility because you don't have to run any servers. You just have to write the code, press one button, and get it deployed. I get an interface to call that. The same thing applied to tensors. So probably all of you used any type of machine learning technologies like a TensorFlow, like a framework from Microsoft. I'm sorry, I don't recall that name, but they all use the tensors as the units of math or of any type of calculations. And basically, in TensorFlow or any other technologies, there is a distributed way that helps you to run your tensor instances on a separate as a separate processes. Basically, you get a distributed way by adding more compute powers, containers, virtual machines, no matter. And also, tensors can be a serverless because the tensor itself is just a piece of code that actually processes your data, gives you the another type of data you can process with another tensor. And also FIFO, philo thing, which is you probably get used to this, is like stack processing. Uh, the scheme actually describes how it works. So imagine that you can write a function that actually the serverless function that actually does some sort of a tail recursion by reducing the number of instances of your data to process. And also you can do that with serverless. It's just easy. There's no difference uh, in the programming model. Would you develop a regular application or the serverless? It just the difference is in the way you call it. So this is what we started to develop as part of Oracle. So Oracle, yeah, I've seen a couple of folks say like Oracle doesn't do an open source. It's like Oracle's more about proprietary thing. Well, it's not. Oracle is all about open technologies, all about community. So we started an open source project that's called Event Project. It's a serverless platform. We have lots of stars in the GitHub. We have a, a real people who use our open source technology, and also we use this technology to do demos. So as part of a team of event project, we care about developers because we want to develop a technology that actually would be useful for people like us, for developers. This is what the serverless is all about. It's all about to give a pretty nice and pretty solid interface for and the programming model for developers in order to reduce the amount of operation thing and get a scalable solutions. Well, just writing a piece of code that all you have to do is just to write few unit tests for that. So it's open source, it's container native because the event project itself works on top of Docker. Developer oriented, we care about the experience. I'm, you're gonna, I'm gonna show you later how we care about that. It's developer friendly. We're open community, and also because we use Docker as our internal container engine, our platform is programming language agnostic, so you can bring your own and runtime. Would it be Python? Would it be Java, Node, was it Kotlin? Just whatever you could put it inside a container. So since the October 2017, we started with four basic programming languages. So basically, those are languages we were good at. So we Oracle, we care about Java. So Java was the official one announced as a technology to run with the FN platform. Then we develop Python and Go because FN itself written in Go, and we have a pretty good team that will do some Python code, and also Node.js because people like to do JavaScript thing with Node as the servers. So yeah, stop talking, stop buzzwording. Let's do some demos. But first, let me explain what that's gonna be. So for this particular session, I prepared a demo which I called the video box. So it's based on a couple of technologies. I use Python and Go to write the code. I use the FFmpeg. I use Scikit Video. I use TensorFlow and OpenCV for the routing. So what the application does, it works with an S3 store. Would it be an open source implementation, Minio, Swift, or real AWS S3 store? So basically, you have a bucket where you can upload a video, and you can point a fan platform application to work with that video. And this particular demo, my serverless application takes that video, parses that onto the frames, do an object detection, which is pretty native to people who've been worked with TensorFlow. It's probably the most asked question on a Stack Overflow. So it does. We do a frame splitting. We do an object detection. We do a 1 second part of video sampling, and we do a general assembling. So basically, at the end, you should get the same video, but with some additional stuff on it. So this is like the very basic schema how it works. We have a Minio. We have a Minio daemon that actually listens on a particular bucket, and we have a fan that runs our serverless application. This is how it looks when we're gonna talk about serverless functions. So we have a frame splitter that takes your video, splits into the frames. We have an we have an object detection function that uses TensorFlow and OpenCV in order to detect objects and do some drawing on that. We have a segment assembler that creates a 1 second video based on the frame rate of your original video. There is a bucket daemon. It's a recursive serverless function that listens on a particular bucket, and when the criteria is met, it performs a general video assembling. I'm gonna show you later how it works in a real life. And there's a bucket cleaner. So basically, my application creates a temporary bucket that puts all temporary files on it. And when the bucket daemon is succeeded, the bucket cleaner just drops everything inside of that bucket and bucket itself. So this is like more detailed schema and the workflow itself. This is what I basically just explained. So this is the diagram that shows a basic diagram of how many functions the serverless application starts and how many different based on the number of the whole iterations. So where the iteration is the number of is a division between total number of frames and frames per second. So basically, it's a length of a video. And probably the beautiest thing that all this demo is gonna run on this small chip. It's an Onion Omega $5 chip, which is amazing. You can put the whole serverless application here, and it's gonna run the whole demo just right now. Okay, let me just show you how it works. So this is the Mini.io dashboard, and I have a video box bucket created. So if I'm gonna upload that video, let me pick one of my favorites. Okay, it's now uploading. Let me check if it runs. Yep, it runs. Okay, I'm gonna refresh page all the time and show you some results. So as you can see, I have a bucket already being pre-populated with images, where each image has a name of its index inside of a video. So basically, it's a sequential number of a frame inside of the video stream. If I'm gonna just I'm gonna refresh it again. Um, okay, let me just download one of these. I'm gonna open this. Okay, this is what actually happens with each frame. This frame was delivered by a frame splitter function. And as you can see, on this frame, I've put our FN product logo, and I also do some detections using the TensorFlow object detection. So each object which is provided by the uh, general model classifiers being detected on this particular image. So the model I've used has 99 different classifiers. So this particular has the TensorFlow detected here only persons, but the detection itself really depends on how big your precision is. So you can detect multiple objects, but you can have an overlaying between the objects because you can detect this. TensorFlow can detect multiple classifiers with the intersection, with their where the intersection is the real in these real and single object it should supposed to be detected. Okay, let's go back to our dashboard. Okay, as you can see, we have a couple of new files. Each file represents a 1 second of a video based on a frame rate. So each file has at least 25 frames combined into a single, into a 1 second of a video. Because my original video has at least like 25 frames per second as far as I can recall. So if I'm gonna keep the refresh that, uh, oh yeah. So as you can see, the temporary bucket is gone, and the art inside of our original bucket, I have a new file, which represents a new video with some object detection. But before that, let me explain you um, certain things, how it works, which kind of technology I use to do a frame splitting, to object detection, and video assembly. So in this particular demo, I used for frame splitting, I used GoCV, which is a wrapper on top of the OpenCV C library. I'm gonna explain later why I picked the GoCV comparing, but not the Python OpenCV. I've used. Let me just go back to my presentation. Okay, I'm gonna use this slide. Okay, for the object detection, I use Python and TensorFlow because it's really simple. You can build a function that actually does an object detection by accepting a list of URLs to your images and gives you back URLs to images with the uh, with the detection and labels being written on that. So because I found itself the Python using the Python code here is very simple comparing to TensorFlow, Go, or C++ library because it's way more complex. That's why people use Python in order to do machine learning because the entry level to the programming language is pretty low. So you can basically learn how to use the very native technology API just in a days, but not spending like a month learning C++ or C in order to write the TensorFlow applications on that. So for segment assembler, I use a scikit-video. It's a library on top of this scikit-learn, NumPy, and yeah, that's probably the main libraries. There are a few additional ones, but I don't recall those. So why scikit-video? So imagine that you should do a video assembly from frames. So you can pick at least at least one very popular technology that you can use, which is the OpenCV that gives you an access to libav or FFmpeg libraries in order to do a stream assembly. However, there is certain problems with FFmpeg in almost every distribution of any open operating system. So the Sicket video uses the particular codec libraries directly. It just goes away. It doesn't use an FFmpeg or libuav code inside of it. Just use the native codec videos. So basically, you can tell the Sicket video that you want to assemble an MP4V codec or H.264 265 codec videos, and it's gonna work. And if you're gonna use the OpenCV with that, the OpenCV stuff is broken. You would fall off back to with the codec which OpenCV called an undefined codec, which is does look pretty bad. Just believe me. So what's next? The bucket daemon. So, but bucket daemon is a tail recursion function. So it uses the HTTP trigger to call itself over and over unless the criteria is met. So it's written in Go because it has to be very fast. Unfortunately, UV loop plus coroutines doesn't give the same level of the performance for this particular task. So what we have left? Okay, bucket cleaner. Bucket cleaner also written in Go because only with Go, comparing to if you're gonna compare to asynchronous capabilities in Go in Python, you would figure out that you didn't have a way to start a coroutine and not await for that. You basically have to wait for that, and if you're not gonna do this, Python runtime would rise an error for that. It's sad that the coroutine was not awaited. However, in Go, you can start a coroutine and then quit from your application with any exit codes, which is way more better, unless you're sure that your task will complete in the just before your application will exit. Okay, that's probably everything. Oh yeah, and yeah, the Sicket video, GoCV, OpenCV, TensorFlow, FFmpeg. Let's go further. Okay, so why serverless is very attractive to developers, but certain developers are pretty afraid of using something new because you may find someone on the web that the serverless it's not pretty mature, and it actually ruins lots of technologies that being developed until this moment. So so the first very good benefit of the serverless is a scaling. You don't have to care about that by yourself. The serverless platform will scale your code based on the number of the requests you submit to call your particular function. Would it be an HTTP request, MQ request, or any other types of trigger a serverless platform provides you? The second benefit is building is a sequential application or the chaining. In certain platforms like Amazon AWS, it's not pretty easy to implement a chaining. So chaining basically means that you can call one serverless function from another because it's not the way it was initially designed to work. However, the chaining itself allows you to build a pipelines of your application. So just recall the serverless MapReduce and the serverless tensors. So this is the way the chaining in sequential application. This is the way you can build the whole flows of your applications in order to complete the task you've been pursuing. And of course, the serverless functions are stateless. So this is like a controversial thing because uh, for some type of functions, the state means a lot. So basically, with a serverless function, you should care about your state of your function. So if you need to store that, just use any file store, database, or any other persistent storage for your result. Or you can serialize your result and send it to another function if you need to do more processing in the pipeline. So if you're gonna download our CLI, this is all you need to start with the Python serverless function. So you need to initialize a function. So basically, our CLI gives you a boilerplate, the basic Python code, and the basic configuration file that is required by serverless platform in order to build your function and provide you triggers to your function. And all you need to start your function is to set your registry. So the registry itself is your Docker Hub name or any URL to Docker registry. So we use Docker registry as a storage for your functions. And basically basically fn deploy is all you need to deploy your function to a serverless platform. This is how the boilerplate looks like. So basically, the interface is pretty simple and similar within other FDKs. So the FDK is Function Development Kit. This is that's a type of library that helps you to focus on your functions development, but not care about the contract between our serverless platform and your code. So basically, as you can see, you can write your pretty small application that accepts the request context. It's a context being assembled from the trigger information. If there's going to be an HTTP trigger, the context itself would contain HTTP headers, the deadline of your function, and lots of very useful things for your serverless function. And also, it accepts the data itself. So if you trigger a function with some data, you're gonna get that through the key value args. And the last argument, which is not mandatory, but sometimes it's very useful, it's an event loop. So by default, it's a UV loop policy class. If you use that to speed up your asynchronous applications with Python 3, you're probably familiar with that. If not, you're gonna get a regular event loop from the async.io library. And all you need to tell how to start your function is to call is a fn handle that accepts a callable object. So this is all you need to start developing with a serverless. So you're probably gonna ask me, okay, callable object is good, but the coroutine itself is not a callable object. It's a different type of object in Python standard library. So we care about that as well. The FDK handle can accept a coroutine type object as well. So basically, inside of the FDK, our code checks what type of object you send that. Would it be a regular callable object that can be detected with a simple callable function? And it also checks if that a coroutine using the typing library, which was introduced in 3.6. Okay, something very special to Python developers that I've been using a lot. So imagine that you write an application with your Python code, and switching to and decoupling your application to a serverless function may take a lot of time. For some reasons, for some type of businesses, the times means lots of money. And all you have to do is to find a simpler way to run your code on a serverless platform. This is why we used a pickle. Who's familiar with the pickle protocol here? Okay, you probably didn't dig into standard library that much. So the pickle protocol gives you opportunity to serialize Python callable objects into byte arrays and execute it uh, anywhere where you can. So basically, it's a serializing and deserializing protocol that helps you deserialize object, send it, and execute it on the other way. But it's not a limit. It's not limited to like callable objects. It also can you can send any type of an objects. And the very beautiful thing about the pickle protocol that it can do a recursive pickle. So imagine that your code has lots of dependencies. It has lots of dependency on standard library, on third-party dependencies. The pickle protocol will go through any dependencies, every link that is defined in C Python, and it will create a serialized objects and send that as part of your like a bigger pickle. So like every pickle of your objects is basically a set of pickles, smaller pickles, which each pickle is your dependency. So this is how it works. You have a Python code. Uh, we have a bunch of decorators which are part of Python FDK that helps you to serialize your object into a byte array, send it to a serverless platform, execute that, and then give you a result of that. And the flow is simple: code to pickle to a fan, unpickle, execute, result, send it back, boom, done. Um, so this is what I've talked like a couple of minutes ago. The serverless actually forces you to pick the exact technology to for your tasks. So if you recall, I've used a couple of technologies here which use a similar core. They were a Go CV and Python OpenCV. So why I stick with this? So initially, I used OpenCV in Python a lot, so I'm pretty familiar with the APIs. I didn't have to go every time to Google and say, "Hey, how can I resize the image? How can I make it gray?" and etc. However, the Python binding for OpenCV takes a lot of memory and also takes a lot of runtime time to start the application. So that's why I figure out like, okay, I have two different technologies that they use different core. They use the same core, but if it's the same core, the whole question is all about a wrapper. So the wrapper here is a programming language. So I have Python with pretty good and nifty interface to do coding. And I have a Go CV, which is Go, and it's faster than Python, unfortunately. So for serverless, I decided to use a Go CV because it's faster. The runtime itself is smaller because I can compile Go into a single binary, but I can't do that with Python. So basically, I have to drag my Python environment, Python runtime from one function to another, and the minimal size of the function of Python environment is like 273 megabytes based on a Debian operating system. So this quote I'd like you to remember. So if you're good at something, you basically need to share your knowledge with any other person of your community. So if you're gonna go to Stack Overflow and search for how can I do an object detection, how can I do image resizing with OpenCV, you're gonna see that there are so many different open topics. So and in almost every topic, in every comment, you can see that certain people provide you an answer, and that answer being used by other folks, but they have problem with running that code. And serverless, no matter what kind of a platform you use, gives you an opportunity to provide a reproducible infrastructure. So basically, you're eliminating the whole bunch of questions saying, hey, that code doesn't work on my platform. I'm working on Windows. I work on Ubuntu, Red Hat, Oracle, or whatever. So if you're good at that, just write a function with a pretty decent interface that people can use and understand, and share that as a serverless function. So So sharing knowledge is what we're trying to pursue. Would it be an open source, or are you gonna share your knowledge inside your company? So this is all about sharing and providing capabilities that people can consume without actually learning a technology how to use it. So basically, you give them an opportunity to run your function without knowing anything, without downloading the runtime, without setting up like any other thing that is required to run your code. All you provide it with a serverless function, or if you talk about FN, you provide a Docker container that you can share through the Docker Hub or your private registry inside of your company. So at this particular moment, we're moving forward to API version 2. When we started, we tried to develop the platform that can be used right away, and for some reason it was not very scalable. So we're making steps forward to our API 2, where we have a split functions from triggers. So at this moment you can define any triggers you like. Would it be an HTTP, MQ, or MQTT? That's all about how you want to run your function. So yeah, this is what I told right now. The FN itself is just a way to run your function with a triggers, and the trigger could be whatever you can implement or you can use out of the box, depending when you're gonna use it. Because we as a core team we're working day nights because we're pretty distributed around the world to make our project better and to deliver a stable open source solution for our let's say open source customers, so basically to our community. um, and this is something we've been care about every time of our work day. So at this moment, we work towards making an Unix domain sockets support. So if you're familiar with that, if you're not familiar with the technology, so basically it provides you an opportunity to run your a web server on top of the Unix socket. So basically, you didn't have to start a TCP connection. You didn't have to allocate a port. So but you can use the Unix domain socket to do request response interchange. We want to introduce this solution as soon as possible because it gives at least 30% of performance upgrade to all our functions that use an HTTP triggers. And also it solves a bunch of problems like a multi-part HTTP requests and more problems that being introduced by our initial design where we used an STD in and STD out to talk with a container to the serialized request by sending them to STD to a writer that being provided by Docker API. So basically, when you start container, Docker gives you two file descriptors where you can write and read from that. So this is the way we've built the interaction initially, but we're making steps forward. We want to make our functions faster, and also at this moment, I'm working on introducing the same feature to Python FDK because I'm using the technology called IOHTTP, which is a HTTP framework based on top of the multi-threading and IOHTTP. It gives you a pretty decent interface to do a serverless programming. And it's pretty easy to implement by yourself because like it's only 5 lines of code. So this is all you need to start with FN project, Docker, Bush, or any other shell technology, and FN itself. And also your coding skills. This is where you cannot go without. So the key takeaways here are pretty obvious. I try to make it clear to the talk. So the technology adoption is not a concern any longer because we're developers. We care about developers' experience and user experience as well. So this is why we're trying to develop a platform, the open source platform that you can use just right away, have a pretty good user experience with that, And you should not be afraid of adopting that, because would be a future of our development, where the DevOps thing operation would just go away, and all responsibility will lay on developers' shoulders, because we need to develop code, cover it with tests, and do sorry, and use something and use better technology that provides a better scaling model for your code, and also granularity. All serverless function should actually do a one thing. So if your function does lots of different things, as I did actually, and it's actually wrong. So I use a function that downloads video, splits into the frames. So it has to be easier. So your function actually should done only one task at the moment. If you need to do more, build a sequential tasks, build a sequential serverless applications. So the application of function itself doesn't have a limit. You can put whatever technology in that you would like to use. So here in my demo, I used TensorFlow that uploads a model into a memory, which is kind of pretty tough operation for the CPU and the RAM, because your model can be pretty huge. If you check the Kaggle competitions, there is a model for emotional detections. The size of that is almost 2 gigabytes for one model that should be uploaded into a TensorFlow graph. And it's very tough. It takes almost a minute to upload it into a memory using 4 cores and 4 gigabytes of RAM. And also, for developers, in order to simplify our life, we need to find a way to delegate all responsibility for hosting your code and execution your code execution. This is what actually really matter for us right now. So basically, if you have lots of DevOps thing, it's developers' fault. You have to find a better and simpler solution in order to reduce your own costs. And this is the links you can follow to find some useful information. We have a pretty active blog on Medium. You can visit our GitHub space. We have a bunch of different libraries. We have an FN, CLI, FN server, bunch of FDKs for different languages. We have an interactive course on Katacoda. Have you used of that? None of you used that? Okay. I'm sorry for that. You basically should try that, because it's an interactive course. You don't have to install everything. You should have only a web browser for that. And also, I'm providing a link to this demo. It's totally open source. You can dig in that. So in order to make this thing more attractive for you, I'm going to show you the final video, and your task, if you're kind of curious about that, to find a problem in this demo and solve that. So let me show you this. Okay, and then we're gonna start a Q&A stuff. Just give me a second. Okay. Low bandwidth. Yeah, it's gonna be. Give me like 2 minutes, okay?
Okay.
I was talking to a person who showed me the numbers. Let me show you the original video here. So basically, it's a snow blast in a Times Square this winter. So basically, you can see that people are trying to clean streets. So it's like ordinary life of Times Square at winter. See it in the video is like 46 seconds. And I'm gonna show you what we get in the end. You probably see certain problems here, right? No? So the first thing is colors. Why everything is blue, and the second thing, why everything is choppy, why it's not similar to original video. So if you'd like to work on this problem, um, just reach out me and show me if you have an idea how to solve this. Just reach out me and we're gonna discuss that. If you're gonna solve this problem, you're a nice, awesome developer. You should get a bigger salary. Yeah. Okay, this is what it is. Just goes in a circle. Okay, Q&A. Finally, we're here. Yeah, first of all, thank you for audience. Thank you for laughing. Yeah.
We don't have any time, but only one question you can take.
Yep. Go ahead.
Thank you for talking. I just want to ask one question. Is there any performance analysis between GoCV and Python wrapper OpenCV?
So you're talking about the performance,
Yeah.
the comparison between
Yeah,
these two technologies.
like runtime. Or
So here's the thing. Python runtime takes some time to initialize itself. So it's more than 400 milliseconds to start a container and 500 milliseconds to start Python itself until it starts executing your code starting from imports. So with GoCV, you didn't have that period of time because you didn't have to start anything until the moment where your code started executing, because you're executed a binary. There is nothing to start, and then basically you get a compiled C code. So it's way more faster. It takes so asking particular questions with the drawing, with the object detection. It takes almost 3 times faster than Python because it takes less memory, it's smaller and faster itself. Okay, thank you.
Yeah, thank you.
Thank you, Dennis.じゃあこれでこのセッションを終わりといたします。ありがとうございました。